Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. So press pause and have a go. Okay, so to do this, the first thing we should do is use the nth term test. So the nth term test is really us finding out the limit of this as n heads towards infinity. But the thing is, finding the limit of this as n heads towards infinity proves to be quite difficult. So we are going to forget about this and just jump to one of the tests. So here we've got when it comes to n factorial, well, or when it comes to exponents, we should think about the ratio test. So here we've got exponents, because the ratio test, you can simplify n factorial or exponents easily. So whenever you see n factorial, but we haven't got n factorial here, but whenever you see n factorial or exponents, you should think about the ratio test. So let's forget about this and just jump to the ratio test. So the ratio test, so when it comes to the ratio test, we always need to compute this value here. So an plus 1 will be this thing here, and then you divide. That's the same as you getting an plus 1 multiplying with the reciprocal of an, which is this thing here. So when it comes to the ratio test, we always need to compute this value here. Well, computing this value gives you this. So now it's just a matter of us tidying this thing up. So looking at this, that's the same as 8 to the power of n times 8 squared, and then if you look at this, that's the same as this is the same as 2 to the power of 2n plus 2. So looking at this is the same as 2 to the power of 2n times 2 to the power of 2, and then looking at this, that's the same as 8 to the power of n times 8. So now tidy this up. So now tidy this up. If you look at this will cancel out with this, and then let me think, and then this will cancel out with this, and then anything else that will then take you to here. And then if you look at the 8, this 8 here, 8 squared will cancel out with this, and then 8, well, this is a 4, so this whole thing here will become a 2. And then you can think of it as being like, well, the limit of this as n heads towards infinity. Well, if you look at this as n heads towards infinity, you just need to extract the highest power. The highest power here is really n squared. Well, if you really want to, you can multiply it out. So n squared plus 2n plus 1. So as n heads towards infinity, this thing here is going to dominate over this and this. So you can forget about these two and just look at 2n. So the point is, when you get to this stage here, as n heads to infinity, the whole thing here will head towards 2. So let me think. So going back to the very beginning, we were trying to determine if this will converge or if this will diverge. We wanted to use the ratio test. When it comes to the ratio test, we always need to compute this value here. Well, this value turns out to be 2. So remember, when this value here is greater than 1, then the original thing that you're trying to investigate will, when it's greater than 1, it will diverge. When this thing here is less than 1, it will converge. And when it's 1, then it's indeterminate. Remember this? We've done this many times. So when we computed this, it equals 2. Well, 2 is bigger than 1. So therefore, the original thing that we're trying to investigate will diverge. Okay, so our series here will diverge just because this is greater than 1. Okay, so our series will diverge.